In this video, we're going to talk about the Java object model. We'll talk about primitives and references, assignment and equality, and object reference creation and deletion. So let's start with the primitive types. And these are the primitive types within the Java programming language. They are the basic types built into the Java compiler. They are part of the language, and there are 8 of them. These are byte, short, integer, long, float, double, boolean, and char. Although there are 8 of them, you can group several of them together. For example, the top 4 all represent integer values. Bytes are typically used to stream binary data across the internet. You would use, for example, a file input stream class, and you'd use bytes to do that. Any type other than these primitive types is handled by reference. Primitive types are special, and they're different to all other types that you could have. So primitive types contain simple values. There are operators for assignment, equality, arithmetic, logic, and bit shifting. And there are object wrappers for primitive types. For example, there is a byte wrapper for the byte primitive type and a short wrapper for the short primitive type. And you would use these wrappers to perform useful operations on your variables, such as comparing variables together or converting between different types. Reference types. A reference is a variable that stores the address of an object. If the variable does not reference an object, then the variable has the value of null. The key point here to remember is that a reference is a variable that stores the address of an object. All non-primitive types are reference types, and this includes strings and arrays. Any string is a reference type. Any array of integers, for example, is a reference type. Any class that you write or any class in the Java library is a reference type. The following 3 operators can be applied to any reference type: equal for assignment, double equals, and not equal for identity and non-identity comparison. The concatenation operator, which looks like a plus, which is a plus, can be applied to a reference to a string object only. So we can't use, for example, the concatenation operator for a bank account class. We cannot add 2 cars together. We can only use the concatenation operator with strings. And why is there this exception with strings? That's because it's very useful. So it's very useful, for example, to be able to add 2 strings together to create a string that combines the 2 strings. You can, for example, design a class in C++ that allows this operator to be used to add 2 bank accounts together, but in Java you wouldn't be able to do that. In Java, this operator can only be used with strings. Other operations that you can have in Java, other operations deal with the object that's being referenced. The basic actions that we can have are apply a type conversion. So if we have 2 very related types and we want to convert between them, access a member field or method using the dot operator. For example, if you want to get the length of a string, you would make use of the length method. So for example, if you declare a string s is equal to new string, you would say s.length, and that would return the length of the string. And also another very useful operation is the instance of operator to verify the type of an object. When we look at inheritance, we'll see that we may not know what the type of an object is. So it's useful to have an operator which verifies the type of an object. Object and reference creation. Creating a reference in Java is not the same as creating the object referred to. In order to create an object, you use the new keyword. And here we have an example of object and reference creation, and we show how there's a difference between the two, and the keyword we use for creating the object is new. We have a 3-line program using a class button, which is one of the graphics libraries. So in the first line, we are creating a reference B, and at the moment the reference B, it does not have the address of any object, therefore we say that it points to null. We create an object by using the new keyword, and we assign it to the reference. So by saying B is equal to new button, what we're doing is we're storing within B the address of the new button object created. So once we've created the object, we can start to think about manipulating the object. And by manipulating, we mean that we can execute any of the methods that have been defined within the class of the object. So within a class, you can define a number of methods, and these are operations that you can perform on the object. Another thing that you can do within an object is that you can initialize any of its values. So at the moment, this button object here, we haven't initialized any of the values. All we've done is created an object, and nothing's been initialized. So for example, there's another object within the button object. So there's another object called the label object, and at the moment we have not initialized this. So you can see here it's set to null, so it has no value. So in order to initialize it, we look through the class and we search for an appropriate method, and there is an appropriate method within that class called setLabel, and you basically say what you want to appear on the label. In this case, we've said no, so it's a button that says no, and whenever I click it, whenever somebody clicks it, some appropriate action happens. So yeah, and an object will have several methods, each performing different operations. Some will be used to initialize values, some will be used to get values, etc. In order to access a method such as setLabel, you use a dot operator here. Okay, so you use the reference to the object that we've created here. Once the object's created, you have access to all its methods, and you access the methods through this dot operator here. Okay, so let's take a look at the difference between the meaning of the double equal sign and the equal sign. So again, this is something that you should know if you've programmed previously in Java or any similar language, but we'll just go over it quickly to make sure you know the difference. So let's say I have a simple computer program here. I'm creating an object of type button, and I'm initializing its label to yes. So button A is equal to new button. I'm creating another button B, also creating an object, and here I have a statement which says button C is equal to B. Okay, so what exactly is going on here? So the first question is, how many button objects are there? So think about that for a second. How many button objects are there? So as I mentioned previously, the thing that you're looking for is a new keyword. So we have 2 new buttons here. Therefore, we have created 2 button objects. Okay. How are they referenced? So the first button is referenced through A, and the second button is referenced through reference B. Now, does A equal B? So double equals mean here is a comparison parameter. Okay. So whereas the equal sign here is used for assignment, if you have a single equal sign, we're assigning an object to a reference, meaning we're storing the address of the object within this reference here. When we use double equals, what we're actually doing is we're comparing two objects with each other. So when I say does A equal B, A double equal B, I'm asking the question, are these 2 objects the same or not? Is it the same object? And the answer is clearly no. Okay, so what we've done is we've created two completely different objects, although they look the same. They both are created using the new keyword. We're using the button class, and we've initialized both their values to yes, so they look the same, but they're not the same. They're two different buttons stored at different address locations within memory. So does A double equals B, meaning are they the same object? The answer is no. Second question, does B equal C? So let's have a look at what we've done. So B is equal to this object here, and when I create a reference C and I say it's equal to B with a single equal sign, what I'm doing is I'm storing the address that's stored in B within C also. So now both C and B are pointing to exactly the same object. So if I'm asking does B equals C, clearly the answer should be yes, because B and C are both the same object. There are two references that are pointing to the same object. So the answer is yes. And I've got a final question here. Does A equal C? And the answer is no. So A and C are pointing to completely different objects sitting in different locations within memory. Okay. So let's have a look at object deletion. So objects have to be explicitly deleted, explicitly created using the new keyword, as we've seen with several examples. However, they are not explicitly deleted, unlike in C++. So if you're writing a computer program in C++, you have to keep track of objects that need to be deleted. Otherwise, you get memory leakage, meaning that you end up with objects not being used, continuously being stored in memory, and therefore you end up with less and less memory available for the rest of your program, and the performance of your program slows down and gets worse and worse and worse. So within C++, you have to keep track of all your objects, and you have to explicitly delete them when you're no longer using them. That's not the case in Java. So Java has an automatic garbage collection system. It searches for objects that are no longer referenced and can be deleted. So it searches for objects that are no longer referenced, and if it finds an object that's no longer referenced, it automatically deletes it, and it reallocates memory to other use. So from the programmer's point of view, all this happens automatically, and in almost all cases no manual intervention is required. Okay, so that's something to keep in mind within Java. Object deletion happens automatically. It's not something that you as a computer programmer need to worry about. So let's take a look at a couple of quizzes now, and what we want to do here is test your knowledge of parameter passing between methods within Java. Essentially testing your knowledge of the idea of pass by value within the Java programming language. Okay, so I have a simple computer program here, and so we have at line 1 public static void main. So we have our main method, and our method starts with these curly brackets here and ends with these curly brackets here. And we know that we have another method here, static void do something with an integer. It starts with these curly brackets and ends with these curly brackets. Okay, so let's have a look at what's happening within each of these methods. In line 2, we're declaring a reference of type integer, and we're creating a new object of type integer and initializing it to the value of 2. And then what we're doing is we're doing something with I. Okay, and do something basically means that we're calling this method here. So we're passing the contents of parameter I to this method. Okay, and then we have a series of print statements. So at the end of this method, we have a print statement. Within this method, we have a print statement here. We're also creating, we're saying I, this I here is equal to new integer 2000, so we're creating a new object. So we're reassigning, we're placing the address of a new object with an I, and we have another print statement here. And we have a number of questions. So let's have a look at the questions. So which of the following statements are true and which are false? Two objects are created. More than one integer reference is created. Line 7 prints 2. Line 9 prints 2000. Line 4 prints 2000. Two objects are deleted. So have a look at your slides, your PowerPoint slides or your PDF slides, and pause this video and try to answer the questions. Okay, so let's have a look at those questions one more time. So let's have a look at the first question. Are two objects created? So let's have a look at what's happening in the computer program. So what we're looking for are the new keywords. So here we have one new keyword and we have a second new keyword here. So the answer is two. Two objects are created. Okay. Second question. Let's have a look at the slide again. More than one integer reference is created. We have a reference here and we have another reference here. So even though they both have the same name, they're both called I, these are two different I's. Okay, so they are two completely different references because they belong to different methods. Okay, and initially this second reference here takes the value of the first reference, but in line 8 this second reference is assigned a completely new object. So we have multiple references. They have the same name, but they are completely different references. Third question, does line 7 print 2? So this is line 7 here, and that is clearly a yes. So initially we haven't done anything special. All we've done is we've passed the value of the first reference into the second reference, and we've just printed it out. And so initially it was given the value of 2, so nothing changes there, and we print out number 2. Fourth question, does line 9 print 2000? So what we're doing in line 8 is we're creating a new object and of type integer, and we've initialized it to the value 2000. So when we print out this parameter, yes, it should print out the number 2000. Does line 4 print out 2000? Let's go back. So this is our line 4 here, and you should have come up with the answer no. So this line here should print out number 2. Okay, because as I said previously, this I is a completely different I than this I here. This first parameter, this first reference continues to point to the first object, and the first object's value has not changed. Its value is 2. So line 4 should print out number 2. Okay. Okay. And the final question: are two objects deleted? So we created two objects. Therefore, yes, we would assume that two objects are eventually deleted. As soon as we have finished with a method, basically we finish with a method when we reach its curly bracket here. So as soon as we reach this statement here, the second curly bracket, its variables and references are what we call out of scope, and they disappear. So all of these, so this reference I here disappears, and therefore this object is no longer pointed to by any reference, and Java's automatic garbage collection system kicks in and deletes the objects automatically. Okay, and the same thing happens when this method goes out of scope, or it ends with this curly bracket. The parameters disappear, and all the objects assigned to those parameters are automatically deleted by the Java's automatic garbage collection system. Okay. We have a second similar quiz to the previous one. So we have a computer program here, slightly different than the one previously, and we have a number of questions here. So please pause the video, have a look at the computer program in your PDF or within your PowerPoint slides, and try to answer the questions. Okay. Okay, so let's have a look at the program. Actually, let's have a look at the first question. So the question is, have two objects been created? So we're looking for the new keywords. So I have a person else is equal to new person, so that's one new keyword. And you notice that there's no other new keyword anywhere else in the computer program. So no, only one object has been created. Okay. Second question, has more than one person reference been created? So let's have a look. So I've got one person reference here, and I've got another person reference here. So we've got two different person references, and one of the person references is called Ellis, and the second person reference is P. So there are two person references. Does line 4 print Ellis? So I create in line 2. I create Ellis. I create the reference Ellis, and I assign it this object, and I initialize its value to Ellis. So in line 3 goes to another method. So let's see what's happening in that other method. In the other method, we pass the parameter into the method through reference P. So I'm passing the address of this created object into P. I'm printing out P. And then I'm saying P.setName to Bob. So I'm changing the name within the person to Bob. Okay, so and we haven't actually created a new object here, so it's the same object that I'm manipulating. So reference P and reference Ellis are both contain the address of this first object here, so they're both pointing to the same object. Okay, so therefore if P or Ellis make changes within the object, those changes are reflected back at both references. Okay, so when I say P is equal dot set name to Bob, it means that the object's name is changed from Ellis to Bob. Okay, so the question asked, does line 4 print Ellis? The answer is no, it prints out Bob. Does line 7 print out Ellis? Yes, this should print out Ellis because this print statement happened before we changed the name. So it was before line 8 where the name change happened. Therefore line 7 should print out Ellis. And line 9 prints Bob. That yes, this should print out Bob. Have two objects been deleted? No, only one object has been deleted because we only created one object in the first instance. And that's the end of the quiz.